Hello and Assalamualaikum. We are from Group 10 and today we will present our group project. First of all, our group project consists of 3 people. First is Muhammad Aizan ADLI, our group leader. Then Nur IZZATI and me, FARIS DANIAL. So firstly, we need to choose a protein. So after a discussion, we choose Felis catus as our protein since we all like cats. The video provided is to show how we get the RefSec of cat. First of all, we need to go to the NCBI website. After that, search for cat in the search box. After receiving result, click the RefSec proteins under the result. Then it will bring you to the page where you can get the RefSec. Next, we go to the BLASP and perform a T+N search using the Felis catus accession number against the nematodes. We use T+N because we want to compare a protein sequence to a nucleotide database. In this case, it can translate in all 6 frames and to allow a protein to protein comparison. We attach a video to show the steps on how we perform the T+N search. So, firstly, we enter the Felis catus RefSec, enter nematodes in the organism and click BLAST. It will take some time for us to get the results. So this is the output of the result of the BLAST. So based on the previous video, we found the hetero-derived glycines as our top result after comparing protein in the T+N. We decided to choose this protein to be our expected novel protein as it have the identities of 74%. Next, this is the result we get from the BLASP of the hetero-derived glycines. The top result is meloidogene enthroloby. I'm sorry if I pronounce it wrongly. So it is the top result, but with an unnamed protein that has 84% identities, indicating that the sequence is novel.
Next, we generate a multiple sequence alignment using MAFFT at EBI. We decide to use 10 sequences that consist of original Curie protein, which is fetus catus, and then the sequence taken from the BLAST result, the novel protein, emu tiger sequence, cheetah sequence, jaguar, striped hyena, wolverine, grizzly bear, and polar bear sequence. That total of 10 sequences. This is the result of the MAFFT programs. There are symbols to indicate the amino acid aligned at the site. So for the asterisk symbol, indicate the perfect alignment. The colon symbol indicate a strong similarities. And the full stop symbol indicate the site that have a weak similarity. For example, here, for the asterisk symbol, this alignment it have all E's, so it indicates perfect alignment. So for the colon, which is a strong similarities, we can see here, this line contain S and A only, which is strong similarities. If you want to see a weak similarities, we can see here, in this line, we have K, K, and D, 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 which indicate a weak similarities. Then we will do a phylogenetic analysis using MEGA. First, we imported the sequence into MEGA and choose muscle to align the sequence. Then, this is the result of the alignment using muscle. Then we calculate the Poisson distance of the amino acid substitution per site. While correcting for the multiple substitution at the same site, the Poisson correction distance assumes equality of substitution rate among sites and equal amino acid frequencies. Next, we develop a phylogenetic tree using a neighborhood joining method. Based on the result of the tree, we can see that this family can be divided into three groups, which are Felidae, Heteroderidae, and Ursidae. Looking at the length of the novel gene, which is melodogyne enteroloby, seem familiar with Heterodera glycine. Other species seems to be more distant and does not share common ancestor. We also do a bootstrap. So this is the result of bootstrap. So based on the bootstrap, the value on each branch indicates the bootstrap value. Note that 100% a node receive 100% bootstrap value, which indicate a strong support for the node. The node is for heteroglycine and the model and the novel gene. Whereas the other node receive much weaker support, such as this node, which get 41 value for bootstrap for node cat and emu-tiger. This is the bootstrap tree caption. We use neighborhood joining method, and interfered from 100 replicates is taken to represent the evolutionary history of the taxa analyzed.
Thank you, Izzah. I will take it from here. For the task 7, the discussion, the main goal of this project is to grasp the principle of database searching and sequence analysis by applying what we learn in class into practice. We complete the task step by step, guided by the questions, beginning with the search for a protein of interest and ending with the development of phylogeny tree of a novel gene derived from a protein of interest. A novel gene, melodogyne enteroloby, can be extracted from the phylogeny protein with the 84% identity. Melodogyne enteroloby, also known as the root knot nematode of the Pacara earpod tree, is one of the most damaging species due to its broad host range, pathogenicity, and ability to develop and reproduce on multiple crops carrying resistant genes. Rather than having a significant function, this protein could be a plant parasite that has the potential to cause significant economic loss in the agriculture industry. Melodogyne enteroloby, a novel gene with the 84% identity and 92% positives, was discovered from the protein sequence of the cat Phylogeny. The score is close but less than 100%. The protein is a novel. As a result, we conclude that Melodogyne enteroloby with the sequence ID CAD 218-15221 is a novel gene. For phylogenetics analysis, we use neighbor joining method, which is based on distance. The branch scales are determined by the number of evolutionary changes for all the distance between them. We can deduct that the neighbor joining tree that cats and bears are closely related. They evolved from a common ancestor as they are shared by two descendant lineages, where the novel gene Melodogyne enteroloby and the sequence obtained from blast Heterodera gelicines share a common ancestor. The values in the bootstrap tree indicates that the strength of a support for the nodes, with the higher the value indicating the stronger the support. According to the figure, the node for Heterodera gelicine and Melodogyne enteroloby is 100%, indicating that the node has strong support. Thank you, that's all from us.